Okay, so we're now going to have our first guest speaker. Ramon from NucliaDB is going to be talking about search, ask, and explore, AI search. Big hot topic at the moment. We've just come back from the Shop Talk e-commerce conference, and there was a lot of talk about AI. Most of it not very well informed. It was all about, yeah, ChatGPT. So I'm really looking forward to hearing a more informed perspective. Ramon.
Thank you so much. Well, first of all, because the previous slides were not showing the proper landscape of vector databases. There was Pinecone, Quadrant, but you see this is more accurate, and NucliaDB is here. So it's just to make sure that we have a proper landscape of what happened since 3 months ago or 6 months ago. No? Everything was mostly built during this time. So, okay, what I'm going to explain is something that may be a bit disruptive, no, for e-commerce, people using Solr and these kind of things. I've been using Solr and Elastic for a lot of years, but it's a bit disruptive, and I'm going to explain what we do, that it's a bit different, and may end up that all of us are not with a job anymore. So just to create proper expectations. Also, be open-minded, because it's a lot of things that we're doing different of the standard way of doing search. Okay. So where is my phone? Here. Yes. Okay, so I'm Ramon Navarro, co-founder and CTO at Nuclia.com. That it's an end-to-end search engine for unstructured data. I'm ex-Ona.com, Iskra.cat, CTO co-founder. I've been in a lot of open source communities, Debian, NUM, Plone, the UPC from Barcelona. So I've been involved in open source. I've built 2 frameworks in open source to provide data layers. And well, I'm fully convinced about open source, and I want to state it clear, because open source also needs to be a business. You can be a consultancy, you can build a more kind of GitLab approach company, where you have an open source side of your company and some private side on your company to make money and to make the investors happy. So first, it's clear that here most of you guys are around the product search domain. That it's, okay, I have an e-commerce and I want to search some kind of product. It's not our base, most speciality, I would say. We are more on the knowledge side, kind of, but with private data. So you have your SharePoint, your Google Drive, and you want to get an answer on the data that you have on your Google Drive. We have some clients that comes from e-commerce, and they are using us, but the result is so much disruptive that everything that it's been explained here, it's kind of, okay, none of this is applied to this kind of use cases. So it's still a really early stage feature for product search. There is also, you already know, the discovery. And one of the things that a lot of people are coming on our platform, it's to do exact close match searches based on really complex and unstructured data, like AutoCAD files and these kind of things. So every time it needs to go. Okay, search. What is for us search? Meaning for Nuclia, we have a source of data that you can plug any Dropbox, Google Drive, YouTube, videos, audios, Zoom, everything that you want that it's unstructured, piece of text, markdowns, everything. You send to our pipeline that extracts everything, piece of information automatically. Everything, it's a SaaS platform, so everything I'm going to explain doesn't involve any engineering. It gets indexed, and we provide search for the user. This is how I'm going to, first I'm going to explain about what we do, and then I'm going to explain what NucliaDB is on what we do. So I'm going to use the... So first, extract. I'm sure that all of you who have faced these kind of problems, you have descriptions of products or images, and you need to extract as much a feature as possible on this kind of data, no? And the way that we are doing it, it's mostly kind of split it in these 8 kind of dimensions, no? First, we extract all possible textual information. So in a PDF, it's easy. You just get everything that it's on the PDF. But if the PDF has images, we also need to get the text from the images. And if you have a video, it's the text from the speech to text, et cetera, et cetera, et cetera. We also are providing this kind of, well, it's not inception, but kind of inception based. No, there is a laptop on your PDF or on your images or anything like that. We also need to create automatic out-of-the-box previews and thumbnails for everything. It's because you really want to show to the user which page and which image. We extract every kind of entity and relations between them. So if it appears my name and the name of the company, it detects that I'm working at the name of the company. We provide domain-specific labels. So I suppose that in Wallapop you have the kind of articles, no? It's a phone, no? So being able to label this. This is also automatic because we provide a tool for annotation that automatically learns how to annotate new content that comes into your system. Then one of the really important things is that we split everything in paragraphs. Doesn't mean that it's real paragraphs. We could call it knowledge blocks because, for example, lawyers, they have a lot of lawyers using our application. They push a contract, and what they want is that it's splitted by the clauses of the contract. So the system is able to automatically recognize visually the documents and being able to split them in a proper segmentation. And being able to extract the text and, what's more important, the embeddings, the vectors, everything that now it's state-of-the-art on providing semantic search. We do a summary, we extract metadata, and we provide also the anonymization because it's really important that if you are working for a government, you make or a hospital or these kind of things, you make sure that all the user data it's removed from the pipeline. Everything is automatic. No? You just send a file and you get all this stuff in a payload. Okay, now we have the extracted information. Now let's go to index. And I'm sure that most of you know Solar, know Elastic, and or Lucene. We are not using any of these things. I was using Elastic for a lot of years, and it was really a pain. So we decided to build our own database that it's not based on Lucene, it's based on TANTB, that it's a Rust reimplementation of Lucene, that it's really fast, scales a lot, it has a lot of features, and tries to avoid the main problem of Lucene, with the same merging strategies of Lucene. Plus this, we also developed our own HSNWB, that it's the vector index. We developed our own knowledge graph, provide indexing. Well, I'm kind of going faster than this thing. So we have a full text index that it's based on Lucene, this TANTB. Mostly BM25, you all know these kind of things, filtering kind of features. Standard Lucene, basic, but instead of Lucene, with TANTB. We have a specific paragraph index that provides fuzzy search and provides BM25 on the block, just to provide relevance on the specific blocks of all the content. We have the vectors, the embeddings. There are a lot of models nowadays that move text to vector. But we trained it our own, focus on information retrieval, and we are retraining based on the feedback of the users, because it's really important that our vectors are really good, you will see later, in terms of given a query, which is the answer that the user is expecting on the vector space, so we can search on the HSNWB. And we also extract all the knowledge graph relations between all the entities, labels, documents, everything that we can connect, we connect, and we index this in our own knowledge graph. Okay, now we have everything extracted, we have everything indexed in our system. Now it's time to search. So first, what we are doing is detecting automatically the intent of the user. You know, in Google, you press 2 + 2, and okay, this is an operational mathematics. Or you say, translate this content. It translates your content, no? Because it's detecting the intention based on the semantic that you're writing on the query, no? So first, we have a lot of models that, for example, fulfill filtering based on the query, no? Kind of, for example, onboarding Spain, no? I get Spain, that it's an entity, then I'm going to add this as a filter to make sure that I'm only delivering information that it's from Spain. And also kind of trying to find out what kind of search the user is doing, no? We have a lot of users just willing to do full text search, no? The kind of, just get something that has this ID. Then we don't need to do a lot of magic, just searching the keyword on the FTS. We also we convert the query from the user to a vector, because when you are searching on semantic search, you need to get the query, you need to back the vector to do the semantic search on the HSNWB. I don't know if everybody is familiar with what is HSNWB. Yeah, I've seen. There are a lot of other algorithms. Scan. We use dot distance, cosine distance. I can go deeper if anybody is interested on this kind of semantic distances metrics. But well, most of this we store. We get the query and we convert to a vector to send to it. We traverse the graph, the entities, and we get the documents and the entities that are shared across these two documents, these different entities. We filter everything that we know that it's not going to be interesting from the user in all the content that we have. And we're talking about maybe, I don't know, 1 billion paragraphs, no? It's a lot of information. So as much as we can remove, it's great for the user, no? To avoid kind of doing a query to a lot of data. Then, well, you know, ranking. Ranking, it's really important. We built our own algorithm to merge the sparse vectors and the dense vectors, distance or metrics. That it's not deterministic, because it depends a lot on the data set that the user has on the system. We have a model that computes which one should be used. And then the re-ranking, that, well, mostly you already know all this. I suppose that's learning to rank, but this, as I said, we're not focused on e-commerce, any product search, or learning to rank is maybe the one that we are less pushing right now. Most of what we do is cross-encoding, that it's really, really a good fit for our use case, no? Searching knowledge on your data. And we also have some features that, depending on which user we are triggering, because we know this on the knowledge graph, etc., etc. And once we have everything filtered, searched, re-ranked, ranked, so okay, now you have this, let's say 100 to 100 possible paragraphs that may be interesting for the user. Now we move all this data to a generative answer model that we train it ourselves, focus on doing two things: answering data from a context, and being able to define a new query given a second question. So in a conversational system, you have the first question, you ask, what I'm going to eat tomorrow? And then you get an answer. And then you ask, and tomorrow? But tomorrow is not tomorrow from today, it's tomorrow from tomorrow. So the availability of being able to build a full conversation. It's something that generative models are super good at, and they have the context. So it needs to generate a new information to say what I'm going to eat the day after tomorrow to the database. Well, mostly in the generative AI, we've been seeing a lot of different techniques. Retrieving information from the BM25 and the dense vector and sending to the squat model. I'm sure that most of you already checked notice. You get the start and you get the end of where the answer is on your text. Well, this was old-fashioned. We did implemented this 6 years ago, and it's nice, but it's not super nice. The second one, that is the one that we have right now, is that given the information that we extract from NucliaDB, we are able to generate an answer, given all this context I've been explaining. Super great, really nice, but what we really think is going to be the key thing, it's the fact of just querying the language model, the large language model. No? You don't need to go through the information retrieval. You don't need a database. We are still not there, but we are working to get it as soon as possible. So it's feasible to query your own data with your own generative model. Well, in order to make this a reality, there is a lot of this word that now it's kind of a buzzword, reinforcement human learning, that the feedback is super important to train the model to know how to answer properly your questions. So we get the feedback of everybody who's using our API, and it really helps a lot. We improve it a lot just with 1 month of reinforcement learning. So I'm optimistic. And just a diagram to show the flow that I've been explaining. No, we get the query, we get the intent, we extract the labels, the vector, and the tokens from the query. We filter them. We send to the knowledge graph, to the JSON view, to our FTS, and then we rank, move it to the generative AI, and send to the user. And this in less than 200 milliseconds, something like that. It's a lot of engineering behind to make this a reality, and a lot of we needed to reduce a lot of our models to make sure that they are delivering super fast, and just this one here may take 20 milliseconds, 10 milliseconds to happen. No? So it's complex to accomplish everything really fast. Okay, so what is NucliaDB on this on all this picture? Well, NucliaDB is a database we built because at the moment we started the company 3 years ago, none of the one that you saw on the diagram were existing. So there is no implementation. Even Lucene, there was no, I think that Lucene added vector search on version 7 or something like that. I don't remember now. But there was kind of a PR for doing that. And it will be interesting to see how all these vector databases, but nowadays there has been a lot of hype on this kind of segment. We are not a vector database. We are an end-to-end API to provide searchability on unstructured data. But we needed to build a database, so we open sourced it. Now it's really nice because we're talking with banks and large corporations that they are happy that their data can be open source in an open source database hosted on their servers. And just the processing side, it's on our cloud, or we can deliver a private cloud. And it's a good model to have an open source component, a really big one, a database. But all the processing things are done on our cloud. Okay, so what is NucliaDB here? No? So NucliaDB has ingest. No? It's all kind of documents, files, and these kind of things, and it has resources, and inside the resources has fields, and these fields are maybe files, links, formatted text, conversations, layouts. We are working to have more unstructured data fields, so we can add more data onto it. It's a fully transactional, distributed database with a distributed commit log. It has distributed indexing. We are providing sharding and replications, not the way that Elastic does, but we try to do in a different way that it's a bit more scalable, and we are cloud designed, so you can install in a Helm chart. You can also install NucliaDB in your laptop, just a single binary. It's written in Python and Rust. The complex things are written in Rust. The easy things are written in Python. So it's easy to learn the first layer of interaction, or kind of the API side. But then if you want to go deeper on how we are doing any crazy thing like merging HSN double Bs or these kind of things, then you need to go to the Rust side. We support binary blob storage. We are supporting S3, GCS, local file system, and Azure file system for storing the previews. So if you push a video, it gets transcoded so it can be reproduced on the web page. So this needs to be stored somewhere. So NucliaDB stores on this blob storage. And we use key value based system. We use TAKB, Redis, Postgres, and we have driver for local file system also. And well, we are agnostic about which KB you are using, so we can implement on top of any of them. Meanwhile, they are transactional. So the database is open source. It provides you to push data to it and to store it and to search this data. But of course, when you push a file, it needs to be crunched and extracted, as I said before. So we have the Nuclia API that it's the private side of Nuclia that you can send to process and collect what you send to process. It's just an API, you send a file, and you get all the payload of everything that is extracted. Just our database is designed for this API, so it really works really well. Then we are providing 4 different flavors of search right now. But in order to make this a reality, we also need some Nuclia API endpoints. The predict intention, what I explained it, knowing what the user is willing to do. Predict the entities, knowing which entities appears on the query. Compute the embeddings. So the embeddings are not computed on the database. And this is something we have clear because we think that the database needs to go fast. No, it needs to do its work, that it's search and storage. All these machine learning kind of things require a lot of GPUs, a lot of scaling problems. So we try to extract this from the problems that the user may have. So the deployment is really cheap. We have this on Raspberry Pis if you want, no? So you can really make this run everywhere. And the GPU requires things that are complex, everything on the cloud. The cloud is designed for this kind of hard things, no? Then generating the answer and providing the feedback is also on the Nuclia API. And so what we provide is a search endpoint. This search endpoint does full text search, exact match, and semantic search only, if you want. We have the find endpoint, that it's to find the paragraph, the information in your documents that you are interested on, or in any place. It provides a mixture of ranking and re-ranking based on dense and sparse vectors. It provides fuzzy search also and exact match search if you want. We have the ask endpoint that it's mostly designed for I'm doing a query and I get the answer with my doc. And you also get which documents has the answer and where you can find in these documents the answer that the system is providing to you. The navigate and recommend, this is, okay, I'm willing to look for things related with Lucene, no? So it creates you more a navigation path of how you can discover between all the data that you have on your system. It's more the knowledge graph approach. And well, I'm nearly ending the slides. I just have one last slide. No, fine-tuning large language models with your own data will kill open search, because what we've been able to see, it's that you can create a large language model with private data. You can query and you get the answer, and you can really reduce the size of this large language model to something that fits in a really small device. So we are still far away, but as soon as we are able to create these buckets of knowledge inside the large language model that you can plug and remove, this is going to allow us to avoid a lot of search problems that we're facing today. And we're already seeing some good results on top of that. It's just still not enough mature for production environments from our perspective, but we think it's a good path to go. And yeah, well, that was the presentation.
Do you have any questions for Ramon?
Ramon, no? Yeah. You mentioned that you are using GPT or a model GPT in order to do the generative. It's something that you develop inside, or you are using an API provided by an external company, thinking that really the cost of training this and update these indexes is really high.
We use, so you have the option on the dashboard that you can choose ChatGPT, NucliaGPT, or we are building new, not NucliaGPT, it's we call multilingual question answering. We have our own. The user can choose to use ChatGPT if they want. I can tell you that none of our users wants to use ChatGPT for different reasons. So they mostly use our private one. But we are trying to build new ones with more support for multilinguality. For example, now you are querying something in French and you get the answer in French, no matter if the data, the document is in English. So the document may have the information in English, but you're querying in French and the answer you're getting is in French. So we are super, we'll try to be really cautious about being always multilingual. And this is really hard. So we are improving and improving, and we are releasing new versions of our own generative. And yes, it's really expensive, but it's our business, no? So we have physical machines with 8100 GPUs to compute these kind of things.
Any other questions?
Thank you for your talk. I have a question about the metrics that you would apply and that would apply to the quality of the generated results or generated summaries. Would they be special compared to traditional search? Like you get a longer text passage and some parts might be hallucinated or not? Or can you just get away with the same old metrics?
The good thing is that we are collecting all the interactions, and we have a system that we train the model to detect if it has hallucinated. No, that just focus on hallucination, for example, that it's something, and we are able to detect that more and more we are getting less hallucination on the system. We are analyzing it, and we are. The good thing about the reinforcement, human reinforcement feedback learning, is that it's a really good technique for easily, without needing to retrain everything, just change some numbers on the model to get better on hallucination and these kind of things. We also provide the user to have a happy face and an unhappy face. A client called when I sent the mail saying, I'm pressing the happy face and the result is not changing because we are not training every second. We are checking maybe once a week or something like that. Please be patient. But yeah.
Thank you. Any further questions? Julian.
Thank you for the talk. At the beginning, I think you mentioned that this kind of technique maybe is not so well suited for product search, no, so far. So for you, I don't know, what are the main limitations or risks maybe for this kind of techniques?
Yeah, for me, is that the user is not used to ask for things. No, the user does iPhone to app. This is not a question. This is a knowledge graph, filter, labeling, however you want to call it, fuzzy search, any of the techniques that exist forever. No. So if the user and I can see, I have my nephews that are 14. They go to e-commerce and they query with a full sentence. And I was saying, but the e-commerce is not going to be able to answer you this. I want I don't know, a phone that has this application. Okay, this is not how it works, search on e-commerce. No, and they said, no, it works. And it looks like some Amazon and these kind of things are adding a lot of the generative searches, no? Because people are getting used to do queries, asking, no, not just the keywords that they want to search.
Okay. So how are we doing for time? Got time for another question or two if people have one?
You can sign up. You can go to Nuclia Cloud and sign up. It's free.
Okay, so let's leave it there. Thank you so much, Ramon.